Hello, my name is Victor Lee with metric number MH19033. Today we'll be presenting on engine design with the subject code BMA 3623. So today my group will be talking about the Toyota Corolla AE86, or more specifically the 4A GE engine that is found in the Toyota Corolla. So we will be talking about the 4-stroke cycle engine, which has the 4 stages of intake, compression, power and exhaust, and we will be mainly focusing on the piston, which is the whole part of this project, and the piston will be explained further by my group mates. Thank you.
Hi, my name is KENCHANA PUTRI binti ROSLAN and my ID is MH19030. So today I'm going to present the 3D drawing piston head and also the methodology of our project. So here is a 3D drawing piston model. We draw using Autodesk Inventor Professional 2022. So here, as you can see, this is the technical drawing of our piston model. We have the top view, the left view and also the front view. Here, as you can see, the bore measurement dimension is 81 millimeter, and included also other measurement as well. So to create a piston for our chosen car, we have to make few tests upon our piston to ensure that our piston works well and could meet the expectation performance. So in order to do that, we use 2 types of engineer software. That is Autodesk Inventor Professional 2022 and also Autodesk Inventor ROSLAN Editor Utility 2022. So first, before we could test our designed piston, we sketch and draw the piston model using our Autodesk Inventor Professional, and then we transfer it to Autodesk Inventor ROSLAN to do finite element method analysis. So through the analysis, we could see how the piston operates and can make any further improvement from the data that we have received. So from the data and some other research we have done, we use information to design and create a good piston. And next is the flowchart methodology. So from the beginning of the semester, our project journey has begun with receiving assignments and explanation from our lecturer regarding task and knowledge requirement. Then we have assigned each member task and work regarding the project, and then we start with doing our research regarding our chosen car engine specification. From the research, we could put to use the information we obtained and start working on the design using Inventor Professional and make analysis tests with Inventor ROSLAN. And lastly, after done with the discussion, the project was concluded and we finished writing the report. And that's all for me. Thank you.
Hi, my name is DINESH. My matrix ID is MH19036. So I'm going to continue with design consideration and properties. First of all, the piston model design. The figure here shows the piston model design and the figure here shows the piston head. Design consideration for piston head. The shape of the piston head is really important to the combustion process because it forms a portion of the combustion chamber. There are some consideration when designing the piston head, which is the piston head should have high strength to withstand the straining action due to pressure of explosion inside the engine cylinder during the combustion process. Next is piston. The piston is actually act as a medium where it receives a thrust from the explosion and transmit the force or energy to the crankshaft via connecting rod. So, design consideration for a piston. The reciprocating action of piston produce inertial forces which are undesirable. So, when we design a piston, it should be lightweight to reduce the inertial forces which will allow higher engine operating speeds. There are several forces acting on a piston, such as inertial forces, thermal loading, sidewall frictional forces, and many more. And for the project, the vehicle we choose is actually Toyota Corolla A86 GE. The reason behind this is because this car is actually a pop culture icon and really famous during the times Not only that, the specs of this car are easily accessible online, and which is really helpful for us to analyze the engine of this car, which is 4AGE engine, thoroughly. So these are the engine specification of our car. So that's all from me. Thank you.
Good evening, my name is Chan Wei Loon. My matrix number is MH19031, and today I would like to present about a result discussion for our project. So the first one is a final sketch of the piston head, which were drawn by my group member, by using a SolidWorks. So this is the 4 different type of view of our piston head. So the first one is a bottom view, second one top view, front view, and lastly side view. Okay, so for the Inventor Nastran software analysis, by using the software Autodesk Inventor Nastran, the static analysis and thermal analysis for the piston head is performed. So in the static analysis, we analyze the deformations and to test the fracture of the model when the pressure is applied on it, which in this case 1500 Newton is applied. While for the thermal analysis is to analyze the model's behavior when a certain temperature is applied on it. So by setting up the starting engine of 298 Kelvin and assuming the temperature of the engine during the combustion, which is on the power stroke, is 2500 Kelvin. Okay, while the coolant medium that were used for this test is stagnant water. Okay, so for this total displacement analysis, okay, so based on the result of the static analysis on the piston head, shows the total deformation occur when the pressure is applied on the top of the piston head. So we can see the most of the deformation that occur is on the top surface of the piston head, and it bended forward when the force or pressure is applied. So if more extra force or pressure is applied on it, this will resulting to the piston failure, or eventually it will fracture. Okay, so the second one is strain analysis. This is the result for the strain test for the piston head, whereas strain is defined as a sort of a deformation that occur when the force is applied and will result into the physical change of the shape or size of the object. So from the figure, okay, we could tell that the area that mostly affected by the strain is quite similar to the deformation or the displacement test, as the physical surface of the piston head it changes and affected. Okay, so next one is thermal analysis. Okay, the figure shows the temperature of the effect. Okay, from the figure we could observe the top surface of the piston head has a highest temperature during the combustion process, and the side wall has a lower compared to the top, whereas there are a gap between them to prevent heat to face indirectly. So second one is heat flux analysis. So the top surface of the piston head is concentrated, especially for the edges. This condition is due to the spreading of the heat to the edge after the power stroke explosion took place. Okay, so next, last but not least, for our kinematic calculation of the piston. So based on our group engine, which is Toyota 4AGE, we have that connecting rod length is 0.12 meter, crank radius of 0.045 meter, and a degree is 75 degree, power is 6600 RPM. So by using the amount we have, so we substitute, we could get a rotational speed of 345.58 radius per second and the ratio of 2.67, sorry. Okay, so next is to calculate the position. So by substituting the value we calculated earlier, we substitute into the equations and we will get x of 0.123 meter. So the next one is a velocity. By deriving the equation earlier, we could get an equation for the x prime, and we substitute again the value we have, and we will get of negative 0.475 radian per second. Hence we substitute again the value by times the omega, which is the rotational speed. We will get the velocity of negative 16.412 meter per second. And last but not least, by calculating the acceleration, so we derive again for the second time of the equation, then substitute it, we will get of negative 7.942 times power negative 4 of the x double prime, and then we times again the rotational speed squared the amount, and then we will get acceleration of negative 94.85 meter per second squared. Okay, so that's all from me. Thank you.
A very good day to everyone. I am KRISHNIYA and my metric ID is MH19032. Now I am going to explain about the discussion on kinematics calculation. What is kinematics? One of the branches of mechanics, kinematics deals with the movement of objects and bodies without consideration to the forces that cause them to move, or in other words with motion itself. However, they can conclude that if an object moves with regard to some reference system, whether because of an external cause or an event that does not change, they can assume it's in an inert state. The system of reference that we adopt will have a significant impact on the transfer. Since the movement is bound to the frame of reference, it is impossible to separate it from the context. Moving to the next acceleration, in the compression stroke from BDC 0 degree to 34 degree of the stroke before to TDC 180 degree as shown by the acceleration graph, the acceleration takes place. During the compression stroke, the upper surface of the piston head was subjected to significant pressure. During the compression stroke, the piston accelerates until it reaches TDC 180 degree, at which time it reaches its maximum acceleration, which allows it to decelerate further. Next is velocity. The graph of velocity shows that the piston movement begins at 0 mm over radian at BDC 0 degree and concludes at 0 mm over radian at BDC 720 degree. A 4-stroke engine's 28 cycles are the same as this piston movement. Lastly is the position. Maximum advantage from high pressure produced during the combustion should come after or around TDC. A value of 0 is displayed in the graph's TDC. The engine's peak pressure is near to its TDC, which suggests that combustion forces are being well used. It was 16 degrees from TDC when the engine hit a peak pressure of 86.4295 atm. That's all from me. Thank you.